In this video, we review the exponent laws. So we're told to simplify x to the power of 5 times x squared. Now, recall what an exponent actually means. An exponent is actually a way to write, let's say I have x to the power of 5. This is a way to write a product, x times, where we have x times x times x times x times x. So x to the power of 5 is a notational way of writing x times x times x times x times x. It means that we have 5 factors of x. So let's try to figure out how we could simplify this. If I have x to the power of 5 times x squared, well, this would really mean that I'd be writing x times x times x times x times x 5 times, and then I'd be multiplying 2 more x's. 2 more factors of x. So let's count the factors of x. 1, 2, 3, 4, 5, 6, 7. There are 7 factors of x. So this is equal to x to the power of 7. Now you can kind of see that if you're multiplying powers of the same base, you should add the exponents. Because if I have 5 factors of x and I multiply by 2 more factors of x, I would then have 7 factors of x. So let's suppose I have x to the power of m times x to the power of n. Well, that's equivalent to x to the power of m plus n. When I'm multiplying powers of the same base, I add their exponents. Now let's suppose in the next example I have a to the power of 6 divided by a squared. If we were to write this out in expanded form, well, I would have a times a times a 3 times 3 more a factors of a. So there's 4 factors of a, 5 factors of a, 6 factors of a. And now I've got to divide that by a squared, which is just a times a. Now, here notice that I can divide out 2 factors of a. So 2 factors of a divide out, and I'm left with 4 factors of a, which is a to the power of 4. Now, something to note here. When I divided by a to the power of 6 by a squared, I was basically dividing out 2 factors of a. So how can we generalize this? Well, if I have x to the power of m, that's like having m factors of x, and I can divide out n factors of x. Or if I have x to the power of m divided by x to the power of n, I'm dividing out n factors of x. So this will be equal to x to the power of m minus n. And notice that that matches the example that we've done above. So it's pretty easy to see when you write exponents in expanded form. The exponent laws are pretty easy to come up with. Let's see. Next we have 2 times x squared times y to the power of 3 all cubed. So let's see what this means. When I have 2x squared y cubed all cubed, well, that really means this cubed here really means that I'm multiplying 2x squared y cubed times 2x squared y cubed times 2x squared y cubed. And now I'm multiplying. Multiplication is commutative, so I can multiply in whatever order I want. I can multiply 2 times 2 times 2, which would be equal to 8. I can multiply x squared times x squared times x squared, which would be x to the power of 6, because I would have x to the power of 2 plus 2 plus 2, which is x to the power of 6. And then I would have y to the power of 3 plus 3 plus 3, which is y to the power of 9. So how can we write, what can we kind of derive from this result? Well, notice here that if I have if I have a product raised to some power, like I have x times y to the power of m, well, that would be equal to x to the power of m, y to the power of m, times y to the power of m. So each factor inside of these brackets gets raised to the exponent m. In the next example, we have a fraction raised to the exponent 3. So let's see. Well, we already saw that when we have something inside of brackets raised to the exponent 3, this really means x to the power of n over y to the power of m. times x to the power of m, or n, over y to the power of m, times x to the power of n over y to the power of m. So now we're in the numerators. When we multiply fractions, we're going to multiply all the numerators, and then we're going to multiply the denominators. So x times x to the power of n times x to the power of n times x to the power of n is just equal to x to the power of n plus n plus n, which is x to the power of 3n. In the denominator, I have y to the power of m times y to the power of m times y to the power of m, which is y to the power of 3m. So what happened here? Well, we raised x to the power of n to the exponent 3, because our numerator is just going to be x to the power of n times x to the power of n times x to the power of n, which is x to the power of n to the power of 3. In the denominator, we had y to the power of m to the power of 3, which is y to the power of 3m. So how can we use this result to write a rule when we have a fraction a over b to the power of m? Well, this is equal to a to the power of m over b to the power of m. Next we have, and we can use these exponent laws to avoid writing everything in expanded form to actually figure out what our simplified form is. So using the exponent laws that I've given you here, I could really just go from this step to this step. Okay? There's no need to show this intermediate step if I'm using the exponent laws. So in the next example, I have x to the power of 3 divided by x to the power of 3. If we were to write this in expanded form, this would be equal to x times x times x, all divided by x times x times x, and 3 factors of x divide out. And I'm just left with this being equivalent to 1. Now, let's see, is there any kind of useful result that we can derive from this? Well, if I remember the exponent laws for dividing powers of the same base, if I have x to the power of 3 divided by x to the power of 3, and I use the exponent laws, well, I would subtract the exponents. So this would be equal to x to the power of 0. And in the first part of this, I said that, well, x to the power of 3 divided by x to the power of 3 is just 1. So that gives us motivation as to why x to the power of 0 is just equal to 1. And this is provided that x is not equal to 0. So this is where x is not equal to 0. In the next video, we'll start to talk about negative exponents.